Good morning, everyone. Thank you for joining me here today. I'm from Microsoft. I work on the product engineering team for mixed reality and have been working on the HoloLens product for the last several years. And it's my pleasure to actually be here in Europe. I believe this is one of the first times Microsoft has actually been here to talk about HoloLens with all of you and mixed reality in general. Just out of curiosity, how many of you have been building with HoloLens so far? A good number of you. That's amazing. And so some of today will probably be explaining why Microsoft wants to talk about mixed reality as a spectrum of devices that goes from holographic to a fully immersive. And so some of this might be kind of introductory for you, but I promise you I have some deeper material towards the end that will kind of address some of the interesting problems that you might be facing. And so to begin with, mixed reality for us is really a generational shift in computing. And if you go back to the history of computing all the way from those gymnasium-sized computers that were very large and had very little processing power to what we have today, which is really the mobile generation, we really believe the next generation will be mixed reality. And the things that are enabling that are kind of new techniques and algorithms for understanding the environments around us, and better processing power, and chips that actually can work on battery power that have artificial intelligence built into them. So that's kind of where we're looking for, is what is going to help us get into the next generation of computing. And where we start is this idea of a mixed reality spectrum. It starts with, on one side, we all live in a physical world, and then we're very familiar with building digital worlds in tools like Unity that and you've been able to live in one or the other, but you really haven't been able to bring either of those together. And when you bring them together, that intersection is what we call mixed reality. It is the blending of the physical world with the digital world. And so to make that possible, we start with what we call the mixed reality spectrum. And of course, on one end is the physical world, and on the other end is the digital reality. When you have very much just a composite image placed over a video stream, that's really what we've been calling augmented reality today. We're familiar with that on our phones, where we have an image or a video stream from our phone, and we're just putting an image over it. It's not really taking into account what the environment is like. I'm not able to actually see the parallax or movement of the image relative to the environment around it. And then, of course, on the other end, when you're fully immersed in a digital reality, you're in something called virtual reality. And both of these are subsets of what we call the broader spectrum mixed reality. And so what we'd like to do is approach the center of this. And this is going to happen with new devices coming out. On one hand, we have the holographic devices. The flagship example of this is the Microsoft HoloLens. And HoloLens is a fully holographic computer. It's self-contained. There's no cords or tethers to a computer. All of the processing power and battery is happening on this device. And it's able to place holograms in your world, as if they were really there. You can look at them from any perspective. You can walk around them, and you can experience them as if they were like a physical object actually present in the physical world. On the other hand, we have immersive devices, devices where you can't see the physical world, but you can start bringing aspects of the physical world into it. And that's where we have devices like the Acer Mixed Reality Development Edition headset, and many others coming from other OEMs, including Lenovo and HP this holiday. And so we have these devices that let us go between these. So let's actually walk through and see what it means to actually move to the center of this spectrum. On the first side, we have the beginning, which we would just call a fully physical reality world. Like we have a room, and you can bring people into it. Once you have people, you can start adding things, like what we would in HoloLens called holograms. And since these are digital artifacts placed in the real world, that ends up being these things are examples of mixed reality, like they're being mixed into the real world. You can then do things like take an avatar, someone like here we have a real human. We can replace that with someone who is actually not physically there, but could be digitally there. And now I brought a person to be exactly in the middle of this physical world. And so I've now mixed like that experience. That person could be experiencing this room from a different perspective, a fully digital world on another device, and could be walking around this room, and you would observe this person walking around. Of course, then I could replace the room entirely with a digital world, and that takes us all the way to the other end of the spectrum, where I have a person who is mixing from another place, could walk around, has a coordinate system, a physical presence in this digital world, but could be in a physical world that looks like this somewhere else. And so on this end of the spectrum, we have something that feels much more like a virtual reality experience. But then when we start bringing in the physical world into this digital experience, it turns into something where you have boundaries. And those boundaries, actually can, curate the experience that you have for this digital experience. And the more that you can bring in the physical world into that digital world, like you can end up closer and closer into the center of mixed reality. And these devices today represent like the beginnings of approaching that center, but they're both starting at the outpoints of virtual reality or augmented reality and moving towards the center. HoloLens is probably the most advanced of these experiences because it does have this ability to actually place digital content in the real world. This spectrum was actually defined in a academic paper in 1994. And so it's an experience or a terminology that we've picked up and have been building on. And the reason why we focus on mixed reality is because Windows is the platform that lets you do all of the above. It gets you all the way from an entirely holographic experience to an entirely immersive experience and can bring you down to the center of mixed reality. And we want these devices to become more complete over time, which will help them become more and more a mixed experience. So given that, I want to say I truly believe mixed reality is in our future. We've seen the beginnings right now, and like what people are doing with Unity and other application tools to build for mixed reality are just scratching the surface today. But it's picking up, and there's more interest every day. Just talking with many of you out in the expo floor today, I'm amazed about what you're all creating. So I want to talk a little bit more about what it means to be a developer for mixed reality. And so far, you're probably thinking, I'm just giving you the superficial, this is just a taxonomy discussion. But I want to dig deeper into like what makes mixed reality possible. So as I mentioned, Windows is a platform that lets you target all ends of the spectrum. And it really starts with this belief that we have called the Universal Windows Platform. It's an API set that lets you build for all of these devices using the exact same API set. If you've already been building for HoloLens, your experience to target new immersive headsets will be straightforward because you already have been using all of the APIs you need. In fact, when we added the support for the immersive headsets into the release of Windows and the Creators Update, all we had to do was add 3 APIs. The first API was, is the display see-through or not? Second API was adding boundaries, because when your vision is occluded and you can't see things, you need to make sure that you don't run into walls. With HoloLens, you don't run into walls because you see the walls in front of you. And then lastly, we added something for motion controllers. All of the other APIs, rendering, sound, and so forth, all existed in the Windows platform because we built it for HoloLens, and so we're picking up on that experience. And with that, of course, you have great tools. All the tools that you're familiar with, including Visual Studio, DirectX, and the Dev Center with all of the documentation. And a growing system of middleware. And we'll talk more and more about Unity as we go forward because it is the best supported tool set for building on Windows Mixed Reality today. So getting into this, I want to dig into, like from a developer's perspective, what makes mixed reality possible? And it starts off with this, what are the interactions with computers? Over the last 50 years, we've started with human and computer. And the interaction between that is human-computer interaction. It's a field that many universities teach as a subject. It's keyboards, it's mice, it's the design of user interfaces, and so forth. But the thing that's really powering this movement towards mixed reality is the fact that computers are able to start understanding environment. And when you bring environment into the picture, you start off with something where humans and environments interacting. We call that reality. You and I are interacting via reality. But when you let a computer interact with the environment, that is something called environmental understanding or perception. And all of the APIs in Windows that uses this understanding of the environment are called the perception APIs. They're the ones that give you the coordinate systems. They're the ones that actually understand like the location that you're in, and like can tell you things like with spatial sound how much how large the space is so that you can have the proper sound effects and so forth. And so that understanding of the environment around you is fueling this growth towards mixed reality. And of course, when you combine all three of these together, you have something called mixed reality. So going next into this, I want to start talking about what makes a great mixed reality app. And it starts with these 7 fundamental features of a mixed reality application. And it starts with, of course, world coordinates. Once you open a device, the tracking system that is built into both the HoloLens and all of these new immersive devices uses tracking cameras that are built into the device. You don't need to set up any external sensors so that you don't need to be locked into a specific location. With HoloLens, you just put it on and go. With these immersive headsets, all you need to do is plug it into a laptop that is running the latest version of Windows 10. And you are then suddenly immersed in something called world scale. You can walk around your entire environment. And you can literally walk around a space as large as this exposition center. There's a few apps in the store for HoloLens that actually take advantage of like building a space that you can walk around. How many of you do have a HoloLens right now? How many of you have opened the app Land of Dinosaurs? And have you actually tried to walk all the way across the entire terrain? Now you have a challenge. Like, it is one of those experiences, if you have a HoloLens, to go download that app and try to walk all the way past the various dinosaurs to the other side. It's quite amazing. So once you have a world coordinate system, it gives you that freedom to fully walk around. And then, of course, like we have these options of how do you engage with that environment that you're creating, whether it's placing holograms in the real world or whether it's an immersive experience in the Windows immersive headsets. And you start with gaze. This is simply just a ray cast from the direction that you're looking. And it's very powerful, it's very simple. From there, we have something called gesture. And this is where you get to use hands to engage with your environment. It's a feature that's only with HoloLens. And it's really important to think about your design. You're talking about human interaction. So I have a challenge for someone here who thinks they're incredibly athletic and can just come up and stand here with their arms up in the air for as long as they can. Any takers? Yep, all right, let's take you. So we're gonna just time you, and so see just how long you feel like it's comfortable to hold your hands up in the air. We often do things where you think about just hold your hands straight up in the air. We're gonna see how long that works. We often think about the place that you put your user interface, and if you make people kind of look up and hold their hands above their heads, when you have your hands above your heart, that is cardio exercise. And so you're going to get a workout here. It seems like you're up for it, though. And so when you want to think about your design, like people like to use their applications. They like to play their games for more than 5 minutes. And so that's part of the design you have to start thinking about with gestures. And a lot of the design that we put into the product has been to design thinking about what is a comfortable range to use things. How's it going? Still going? So far, so we're going to keep going. So after that, you have voice commands. And so HoloLens is built in with a microphone array that can pick up your voices. All of these other immersive headsets either have microphones built in or they have a audio microphone jack that you can plug a microphone into. And this is built into the Windows platform. You can actually build dictation or commanding APIs, and it becomes a very natural way to engage with your environment. If you start thinking about digital characters, you can talk to them and command them. How's it going? Is still good? Well, I think we've made the point, but you're kind of like, you don't want to have your users holding their hands up very much. Thank you very much. So, after voice commands, like the next thing that we've introduced is motion controllers. And this is actually designed specifically for the immersive headsets. And they're using the same world tracking cameras that are built into the headsets to understand the position of where your hands are. And after that, you have some of these really interesting spatial features. The first is spatial sound. And it's built on years and years of research in the larger community called HRTF, or head-related transform function, where you can actually place a sound as if it's coming from a specific 3D location. As you go towards it, it gets louder. As you walk away, it becomes quieter. And you can actually create this very immersive experience. Many games use this to the effect that they can create kind of hide and seek or like look for the radio signal kind of sounds. And lastly, with HoloLens, you have something called spatial mapping. And this is the feature that actually lets you see the surfaces of the world around you so that you can precisely target where you want to place assets or holograms. So with all of that, like you have this table of features. And as I mentioned, all of these devices are coming from both ends of the spectrum. On one side, you have immersive devices that at this point don't know very much about spatial mapping. They know a little bit about the environment because they can create coordinate systems, but they don't know anything about the surfaces around you. And HoloLens, where it is further into the middle, and really the only thing it hasn't supported yet is the motion controllers. But you can expect this table to fill out over time, and that journey towards mixed reality to continue towards the center. So with that, I just want to cover some of the developer resources available to you as a mixed reality developer. Of course, documentation is one of the most essential pieces. The fastest link to get to our documentation is aka.ms/mr. And it has both design and developer features for you. But the really valuable part for most developers getting started is all of the tutorials that come out of our Mixed Reality Academy. And all of these tutorials are based on Unity. They start with teaching you how to do like all of those features from start to finish, gaze, gesture, voice, spatial sound, and spatial mapping. And then go deeper in later courses to teach you some of the advanced features like tag-along and placement of scripts, spatial understanding, locating where a floor or a wall is, or being able to find a shape so that you can find a sofa or a couch and build your game around that. And this is how something, if you've played the game Fragments for HoloLens, one of the characters, Admiral Kirkland, actually finds your sofa and sits on it during the game. And it's kind of one of those moments where you actually think, well, how did she know that was a couch that I could sit on? It's in the documentation for you to find out so that you can do the same thing. Beyond that, we have many open source projects. Galaxy Explorer is the quintessential end-to-end application. It was voted on by the community in a project we called Share Your Idea, and then we open sourced it for everyone to be able to see it end-to-end. We've then taken that application and moved it over to the immersive headsets. And over time, it will be available on all of the Windows devices that run on the Universal Windows platform, and again, makes use of Unity. So for all of the HoloLens developers in the room, I'm sure you know about the toolkit, because the toolkit is by far one of the most widely used open source projects. It's where the software platform is advancing as fast as the community can add features to it. And it obviously includes some really interesting things like being able to share experiences between devices, so that two people wearing a HoloLens or one person wearing a HoloLens and another person with an immersive headset can actually look at the same content in the same location and feel as if they are both looking at the same thing. Beyond that, we have all of the tutorials that are in the Academy as open source projects as well. Of course, one of the most important things that developers need is they need to show off their work. You want to advertise the work that you have, and we have two ways of doing this. The first is mixed reality capture, and this is built into all of the devices, whether it's HoloLens or on the Windows desktop, where you can actually just get a video capture of the experience from a first-person point of view. And that has a lot of advantages. It's very simple, it's very easy. On the other hand, if you've ever watched someone with their heads attached to a camera, it's not that fun to watch sometimes. And so you'd prefer to have something where we call it spectator view. It's a third-person perspective where you see both the person wearing the device and the content they're looking at. And this is an open source project that's also included in the toolkit that we have. So, of course, the last thing is the built-in tools. You have both Mixed Reality Portal, which is new with the Creators Update. It gives you the ability, if you don't have a device, as many of you I know don't yet have one of these, but are looking forward to getting one, you can actually get the latest version of the Windows 10 from Windows Insider program and load up the Mixed Reality Portal. From there, there's an option for you to say, I'm a developer. And as a developer, you can use simulation. You can use a gamepad or a joystick of any kind or keyboard and mouse in order to control your experience walking through the Windows shell. And the Windows shell, we call it Cliff House, lets you place content around your world. I was going to demo it for you upstage, but I left my laptop over there. So feel free to come over to the Microsoft booth afterwards, and I'll be happy to show you how the mixed reality simulation lets you walk around the Windows immersive shell. Of course, the other thing is the Windows Device Portal. Windows Device Portal was developed for HoloLens and determined to be so valuable that we put it on all of the platforms, including desktop. And so this is a place where you can find out what is the frame rate of the application that's running. For instance, if you buy an app from the store and you think it's not a great app, you can just check, is the frame rate low, and then give feedback to the developer to improve their frame rate. And that's just a tool that's available in Windows. You can find it through the settings panel, the settings app for Windows 10. So the last thing I wanted to do was, last week, I got the privilege of working with Unity to review hundreds and hundreds of submissions for a contest for HoloLens, being able to see what many of you were interested in supporting building applications for HoloLens. And I wanted to give some feedback because, like, reading through many of them, they had a perspective of great ideas. They started somewhere and suggested what they wanted to do. And a lot of them start with, I have this existing application. It was built for VR, or it was built for Windows, or built for mobile, and I want to bring it to HoloLens. So given that, I have 3 suggestions on what makes an okay idea or an okay app and make it a good app and possibly a great app on HoloLens. And the first one is, of course, make use of the environment. HoloLens and the holographic platform is uniquely suited to actually use the environment that's around you. And so if the ideas that you're bringing to HoloLens aren't actually present in the physical world, there's no idea that requires the physical world to be around you. Whether it's a specific location or a general, like anyone's home or office, just think about how the physical or environment fits into the application that you want. And the second one is, of course, make use of sound and voice. 3D sound, being able to place that around you is an amazing experience. And so as you add voice to the experience, it becomes more natural as well to command and experience these applications. And then lastly is actually stabilize your experience. One of the things that you have to think about when you're wearing either a HoloLens or an immersive headset is you have a display attached to your head. And that display is basically trying to figure out what should it be displaying at each frame in order to match the environment that's around you. Just think of this. I want to put a hologram, say, up on this podium here, and I need it to stay very still. The tolerance that the human eye has for understanding how much that hologram could move before that immersion breaks, before that belief that this hologram is actually here, is the width of a hair held at arm's length. That's 0.15 milliradians of drift or jitter. You're not, like, the tolerance is very important. And so HoloLens actually has hardware built in to take care of this, and so does the Windows desktop for these immersive devices. But there's one thing a developer has to do, is they have to actually set a focus plane for where objects need to be stabilized, where they need to stay still. So that's your responsibility, and HoloLens picks up the rest of it. So in the last 2 minutes here, I just want to explain what is HoloLens doing in order to actually stabilize these objects. And it's a technology called late-stage reprojection, or LSR for short. And so here's how it works. If you think about a normal 60 frames per second render loop, that means that you have about 43 milliseconds from the point where you start rendering an image to the point that it's actually finished and displayed to the human eye. And so if we, just as an audience, kind of look to your left and then just turn your head to the right over 2 seconds. So let's all just do that, and just like that. If you think about that, that's 120 degrees of movement. And if I'm rendering at 60 frames per second, I'm moving 1 degree every frame. And if I'm looking at an object that's placed far away from me, that could be several, like half a meter or possibly an entire meter of movement for every degree of difference. And so I need to take care of that. 43 milliseconds is actually quite a bit of latency from the point where I start drawing something to where I see it, and we'll see that in a second. We need to reduce that latency to less than 15 milliseconds, ideally less than 10 milliseconds. So even at the technology here, where I have 16 milliseconds to display all of the frames, that's too much. I can't do it. And so we have to do something to improve this. And so what we've built into HoloLens is custom hardware to actually adjust the image that's rendered, that bitmap that is rendered, to make it a better image that's displayed. And then we adjust that image for every color projection. So we're taking effectively a 60 frames per second render loop and turning it into 240 frames per second. We're upscaling it that much. So here's a very quick demonstration of what that means. Here I have a hologram standing in the hallway. Imagine that he's about 2.5 meters away from me. And of course, holograms are a bit transparent because we're only adding light to the eye. I can't take light away from the eye. And if I do that, move 1 degree for every frame, if I had the top row where I am not doing any adjustment, this is how far he moves. And if I'm doing that every frame, at 60 frames, you're starting to see double. This image gets bounced back and forth. And then the next thing is, of course, I want to bring the environment into the experience. And I look at this gentleman, and he is supposed to be standing behind the hallway or the door. To do that, I have to bring in that spatial mapping mesh and cover over the left half of him. And so I get the illusion that he's standing behind the doorway here. But now, if I have him moving and drifting, half of his body is moving. And this is, of course, what you end up seeing. Over time, you get this sense that everything is a blur. And so you're going to get this motion where these things come together and it's blurring. So now let's look at it where I've taken the latency and I'm just looking at the draw effect away from 43 milliseconds. So that was effectively 3 degrees of movement to 1 degree. And if I did no adjustment to the image, I'm actually going to see each of those colors shown individually one by one. And you're going to have something that looks a bit like what we call color separation. And I'm sure many of you developing for HoloLens have done this, where you've seen the display that you've put on create a color separation. This is an immediate signal that you're not stabilizing your holograms. You're not using the hardware built into HoloLens to create a cohesive image. This happens frequently for display-locked content and often for cursors, like things that are display-locked. So if I fix that and bring all of that together, I get to something that is actually very straightforward, just these 2 images. And there's one last thing I can do to improve the prediction, which, again, we do in the platform, and that is prediction. Where you're moving your head, I can predict where your head's going to be 15 or even 30 milliseconds from now, because you don't have spider reflexes. None of you are Spider-Man. If you are, I want to meet you. And we can then predict so that where we start rendering the image to the place that we finally display it is exactly the same. And so with that, I just want to say thank you for all of you to join me, and feel free to come in back and talk with us at the Microsoft booth. Thank you.